Hello everybody, this is the notes for Honors Geometry, section 2.5. What we're going to be doing in this section is actually kind of a little bit of review. Well, at least part of it will be. We're going to be solving some algebra equations. But what's going to be different is using the deductive reasoning. That's making statements that we know are true because of certain properties. So, and we're going to also do some geometric ideas using the same deductive reasoning. Okay, so when you solve algebraic equations, as it says on the top there, you are using properties of algebra that allow for each step to be correct. So, hit pause, take a couple minutes, copy these things down. You have seen these things before. Now, like I said, you have seen these things before, but what you have, the idea of these things is, you know, this first property, this addition property. If you got x minus 5 equals 6, to solve for x, you would add 5 to both sides. The reason we can do that is this addition property of equality. It says that if two things are already equal and you add the same thing to both sides, the result is going to stay equal. Same idea for the subtraction property of equality, or multiplication property, division property. Those are all the same idea. Okay, and we use those in the different ways, but we always use them solving equations. The last one here, the substitution property of equality. Basically, it says if you know two things are equal, you can take one of those things out and replace it with something else. So kind of like when we solve those systems of equations. If we had 3x plus 5y equals 7, and we solved one equation for x, we said x equals 2y. Well, we would do the substitution. We would take the x out of the first equation and replace it with what it's equal to. That's the substitution property. You're taking something out, replacing it with what it's equal to. Okay? The last one on this page, the distributive property, that's when you have a number or a quantity multiplied by two or more terms that are being added or subtracted. So when you do that, you get a times the first term, b, plus a times the second term of c. Okay? These are all the properties that you will use solving equations. So let's take a look at an equation and use these properties. All right, so like it says, you want to solve the equation and write a reason for each step. All right. So, solving this equation. First thing I would do, add 4x to both sides. Okay, first off, we know we can do that because we're adding the same thing to both sides. That's the addition property of equality. And that's all you need to write for that step. So when you do this addition property of equality, adding 4x to each side, you get a new statement. 7x plus 8 equals a negative 34. All right, the next step in solving this would be to subtract 8. Well, we have two things that are equal, the 7x plus 8 and the negative 34. We're subtracting the same amount from both sides. That's your subtraction. Subtraction property of equality. We know we can do that because of this subtraction property of equality. So when we take this step, what we get is 7x equals a negative 42. And now the last step in solving for x would be to divide by 7. But you're doing the same thing on both sides. So we're dividing both sides by the same number. Division property of equality. And when we do that step, we get x equals a negative 6. And that's our answer. Okay? So this is the idea. We're solving. This is solving the algebra. That's nothing new. Nothing's changed with that. But what we're doing is this idea of deductive reasoning. We know the steps to take. But what we're doing is applying those steps, making those conjectures. Oh, from here I'm going to go to, from the given, I'm going to go to this, then I'm going to go to this. We're also giving the reasons. That's the whole idea of deductive reasoning. You're making conjectures based off of things that are accepted to be true. properties of equality are accepted to be true. Okay, that's it for this first video. Please pay attention to the next one. It's a little bit more challenging.